the magnet pulls on the motor of the car to slow the car down. And when the car goes over the magnet, it causes it to spin, generating electricity, which can be stored in a nearby battery. The electricity can be used to power surrounding streetlights, saving valuable tax dollars for the city. We would now like to share a screen.
All right, go ahead.
Here is our digital model of our innovation. The magnet, as you can see, is installed vertically underneath the ground. The gray cylinders on the car are the motors, and the magnet pulls on the motor, slowing the car down. And then the car drives over the magnet. Its motors pull on one of the magnetic poles, causing a rotation. The electricity generated through the electromagnetic induction will be stored in the battery, which can be attached to wires to give to the streetlight.
So here is the digital model. So these gray cylinders that Hunter was talking about over here. Here's the magnet, and here.
So you might be wondering how we came up with this idea. Actually, we were toying around with an idea of putting a magnet on a car wheel so that it rotates and generates electricity with, again, electromagnetic induction. However, as we went along, we thought of something better, a magnetic speed bump. We ordered some magnets and used motors from the kit and made our prototype. We got a base from our science room and tested it with the voltmeter found in the kit. And now Arhan will show us the prototype.
Thank you, Hunter. So here, as you can now see, so this is our car that we are going to be using. Right now, I have marked, after we tested it, where our how far it goes without the magnet, and then we'll see how far it goes with the magnet. So let's test it out without the magnet. So yes, it is right over here. And now we will place this magnet underneath. So I'm going to place it right over here. Now let's see. So as you can see, the magnet actually slowed down the batteries and the motor. And we put some metal underneath the car over here. Over here is a magnet that kind of simulates what a car will feel like because it is made out of metal. So the distance is approximately 5 inches. So obviously this is not a real prototype. We did not have time to refine it because of the COVID situation, so we could not show how the magnet spins. However, this can provide a good idea of how it's going to be. So now, our main purpose is saving lives by using magnetic speed bumps. However, a valuable byproduct of this is the electricity generated by the magnets rotating.
We have calculated that our speed bump can generate on average 2,000 watts of electricity for the average of 1,000 cars. According to a local assistant engineer, the average street light uses approximately 80 watts per night, which means that with a traffic of 1,000 cars, this magnet can support 25 streetlights. The cost of providing electricity to one streetlight is usually about $500 per year for the city. Each of these speed bumps can save about $12,000 per year with only 1,000 cars per day. Easy enough to get near residential areas.
So this idea is primarily...
You're now at the 5-minute limit.
All right, you guys can wrap up now.
Oh, okay.
The other teams, I'm sure, have amazing ideas, but these are why we're different. The innovation makes the world safer, and by generating electricity, literally brings us to a brighter future. If this is enough for first place, then we'll step aside.
We thank you for your time and hope you have a great rest of the day.
Judge Terry, do you have any questions for the team?
Yeah, so I'd like to know what the next step is. How do we make the leap from the demonstration that you did to show us how it slowed down that vehicle to kind of putting it into practice in the real world?
Well, first of all, we're going to start out small. We're going to sell it for approximately $5,000 to the government, because that around $4,500 is what it costs to make it, to install it, make it, buy all the magnets. Then after that, we can start selling it to commercial users if we make this product, right, with a higher cost. Finally, when we get a steady cash flow, we can start setting aside a few to give away for free to underprivileged communities.
Thank you.
Easy parking. Are you ready to tell us how to park easier?
Yes. Hi, our team, Designer Daisies, consists of 4 middle school students. Our names are Ashna, Shifa, Tarini, and Greg, and we're proud to represent girls in STEM.
The problem that our team decided to solve is how long people spend in large garages such as the DFW airport to find a spot that fits their needs. Some specialized spots include handicapped, near an elevator, first floor, or electric car friendly. As you can see on this graph, 63.2% of American drivers have children, 6.2% drive electric cars, and 12.8% are disabled. This means that our product would help 81.8% of American drivers. In large parking lots, while trying to find a spot, it wastes precious fossil fuels, and it also wastes the driver's time. One of our team members' dad has epilepsy, and because of this, he's unable to drive. He relies on other people to drive him, and they often struggle to find him a spot that fits his needs. Because of this, he inspired us to create a solution for everyone.
Our solution has 2 parts, the Easy Parking app and the Arduino Uno. The Arduino is connected to an ultrasonic distance sensor, an NEO 6M GPS module, as well as a Bluetooth module. To program the app, we use the MIT Inventor software. This is the coding of our app. So customers will first download the app and create an account. Then they'll be directed to the preference page. They will then select their preferences, such as if they want to be near an electric charging station, on the first floor, or near an exit. The Easy Parking app then finds an available spot based on your preferences and generates the closest spot available and gives you directions right to that spot. For example, a handicapped person in a wheelchair would want to be on the first floor and near an elevator. Our app will take them right to that spot. The preferences and locations are then both saved for the driver for the next time the app is opened.
The app is refreshed constantly, so if a spot is taken, it will immediately notify the driver with a sound, and he or she will be sent to the next closest spot. The second part of our solution is an Arduino Uno microcontroller board connected to an ultrasonic sensor, a GPS module, and a Bluetooth module. The ultrasonic sensor works using echolocation and sends out ultrasonic pulses that are then relayed back once they hit an object. We would use this to detect whether a parking spot is occupied or not. The GPS module over here locates longitude and latitude using satellite and would use this information to know the exact location of each parking spot. The information is then relayed back to the app by means of Bluetooth, hence the Bluetooth module, which gives our Arduino Bluetooth capabilities.
Our project is innovative because it helps drivers find, pick, and receive directions to their preferred spot. It will also save the driver's location of the spot. Individuals with special needs, such as an athlete on crutches, will especially benefit. We shared our ideas with our entire school, faculty, and staff through our website and received helpful feedback. Our first step in implementation was to try the device at our school. We secured the device to the spots in our school with adhesive road tape and used reflectors to prevent damage.
Our supplies cost a total of $54.99. A typical electrician costs $16.77 per spot or less. This would mean that our total for each Easy Parking unit is $71.66. We then spoke to engineer Mr. Barry Bartlett, who told us that with the help of professional manufacturers, they could help lower the cost and bring our product to the market.
Throughout the whole season, we investigated many projects, such as air vents, solar panel cars, and windmills. We researched and met with experts such as former North Carolina Senator Eric Rees about our potential solutions and realized they already existed. We then decided that we wanted to focus on an idea that was more meaningful to us as individuals. And that's how we settled on the Easy Parking system. This is a picture of our first prototype. It's a cardboard parking lot.
After we finalized our project, we presented our concept to experts Lorena Toffer and Mr. Cox. Ms. Toffer, who helped design the new DFW parking lot A, said that she would be interested in using the easy parking system in her parking lots once it came to the market. Then we talked to Mr. Cox, a patent attorney, and he confirmed that our project does not exist.
Throughout Edison's life, he faced the disability of not being able to hear. Thomas Edison created telegraphs and phonographs to help overcome his disabilities. Our project, like Edison's inventions, benefits people with disabilities. And as Thomas Edison said, "I have not failed, I have just found 10,000 ways that don't work." Throughout our process of creating the Easy Parking app in Arduino, we overcame many difficulties but eventually succeeded. We believe that our team should win the Thomas Edison Pitch Contest because our innovative parking system will help communities, especially those with special needs. Thank you.
Thank you.
Nicely done, right on time.
Yeah, just wanted to know what was the estimated market cost when you went to the professional to get that done, from $71 and some cents down to what was the market cost?
He said that we would be able to reduce it by 40% with the help of professional manufacturers, and then we could get our app onto the store for 99 cents.
Awesome. Thank you.
Thank you.
All right, that brings us up to our final team in this category, and that's Dust Be Gone. Sounds like something my wife is going to like.
Hello, we are the Hawker Builders. We are a team of 4 girls in Dallas, Texas from the Hockaday School, and my name is Anya.
My name is Stella.
My name is Yanit.
And my name is Anisha.
We are so grateful for the opportunity to compete in the Thomas Edison Pitch Contest. The problem we solved is that air filters are inefficient, expensive, difficult to replace, and bad for the environment.
Not replacing an air filter decreases the air quality and allows dust contaminants and mold to enter the air system, which can cause horrible illnesses. If you inhale an excess of dust particles, it can clog up your lungs, which can be fatal.
Also, when the filter is filled up, dust settles on the Freon coils, fans, and machinery inside the HVAC system, which causes them to break. Broken Freon coils are very expensive and difficult to replace, as each coil costs $3,000.
Air filters are also very costly. On average, a household spends $240 per year, which might not seem like a lot, but our school has 752 filters, which means we spend over $180,000 on air filters per year. That is outrageous. Because single-use air filters contain fiberglass, they are impossible to recycle, meaning they create tons of waste, 480,000 tons to be exact, per year. Removing that amount of waste is equivalent to removing all the plastic straws in the ocean every year for 280 years.
Air filters have not changed for a long time, and we believe that they can be much better. Thomas Edison once said, "There's a way to do it better. Find it." So we created the Dust Be Gone. The Dust Be Gone is a permanent air filtration system which you purchase once, install once, and never have to buy again. It is installed in the HVAC system and runs using power from the electrical mains. It uses electrical charges to pull dust particles out of the air using a method similar but different from ionization. On the top of the system, there's a patch of small metal spikes which are hooked up to a negative electrical main. The main supplies them with electrons, and the electrons flood into the space. When the spikes are overloaded with these electrons, it shoots them out into the airflow, where they attach onto dust and mold and particles that are inside the airflow. The particles then become negatively charged because of the electrons. This plate here on the bottom is positively charged because it's hooked up to a positive electrical main. The positively charged plate attracts the negatively charged dust particles out of the airflow, which means that it's filtered.
We met with our physics department to better understand the mechanics and physics of what we wanted to do. After refining our system, it was time to try and execute our prototype.
First, we began by drawing out our system to get dimension. Then, after making a list of the materials we would need, we went to Lowe's to buy our products, along with some extra to allow room for air. Next, we worked in our engineering lab to make the box that contains our prototype system and installed our metal components and electrical wiring. Then we installed our Arduino motorized component.
The issue we ran into was that the dust would not remain stuck to the plate for more than 36 hours. So we installed a wiper system which wipes the dust off the plate once daily. From the parts supplied to us in our maker's kit, we used an Arduino, a solderless breadboard, a battery clip, a servo, connection wires, and a button. Here is our Arduino program. The program instructs the Arduino to move the servo 90 degrees to the right and 90 degrees back to the left at the push of a button. In the future, we plan on having a timer which would have the wiper run automatically once daily, but currently we only know how to write a button-operated program.
That is the Dust Be Gone. This system is better than all of the existing solutions in that it resolves all of the issues that we spoke of earlier. The Dust Be Gone does not create any waste, and it never has to be replaced, meaning that the risk of airborne illnesses and mold is much lower. The system costs around $110, which the buyer only spends once, plus minimal electrical fees, which means that schools and office buildings would go from spending absurd amounts of money every year to spending a low amount of money once.
Our team came up with a detailed marketing strategy, as you can see here with our pie chart and flyers, and here's a breakdown of our cost. Our materials will cost around $56, and then manufacturing costs will be $60, and we are going to sell our product for $110. Our target audience is schools and office buildings, as they have a lot of air filters and spend a lot of money, and they will like our product because it's cheaper and they won't have to replace it.
Here are some of the .gov and .edu websites we used to research our project. Because we came up with it on our own, we know that it's completely original. We researched to confirm this and met with a patent attorney, Mr. Cox, and did not find anything like it.
Our product deserves to win because it is an original idea, it saves the user a lot of money, and it solves many problems associated with normal air filters. Our first servo strip stopped working, so we had to disassemble and reassemble our prototype. Whenever Edison encountered a problem, he took it as a learning opportunity and moved forward, and so did we.
Thank you so much for listening, and we hope your quarantine is going well so far.
Okay, how did you get this idea? What made you think of doing something like this?
Well, we spoke with a bunch of architects. We wanted to fix a problem that large-scale buildings like our school face every day. So we spoke to an architect. Her name is Miss Brandt. We spoke about her earlier, and she told us of a few different issues that big buildings face that are product-based and not, architecturally based. And so she told us that one of them is the fact that air filtration has kind of been the same for a long time, and it's just becoming more inefficient. And so, as we looked into the problem, we did more and more research, and we found that there's a lot of issues that arise from the lack of replacing air filters. We also found that they're very expensive, and people tend to not replace them. I know my family, we actually went like 3 months once without or not 3 months, 8 months once without replacing our air filter, which is not healthy. So we decided that, clearly it's a big problem, and we wanted to do our best to solve it.
Thank you.
I have a quick question. So talk to me a little bit about the market for this. Are you looking at schools and large buildings? Or are you looking at homes? Talk to me a little bit about that.
We would want to focus first on schools and office buildings and, focus on that because there's a bigger need for it there. Because obviously, homes, they don't have to spend huge amounts of money because they have far less air filters. But once we have, refined our system and, there's a solid flow of money, we would hope to maybe make this system a little bit easier to install, condense it down a little bit. And then we actually talked to Lowe's about selling it there for, where people generally do buy an air filter right now.
Thank you.